Thanks for joining us for this special preview. And now, our feature presentation.
Same rate. In other words, if we went to the moon, there would be no atmosphere, and dropped a feather and a rock, a tennis ball and a basketball, which one hits the ground at the same time?
Since they went all the way to
Yeah. Let's see, we're on Earth.
Yeah.
So bricks have to fall first.
I don't think that's how gravity works.
So what's the answer?
They hit the ground at the same time.
Do they?
Yeah.
We need a feather and a brick.
The reason for these objects hitting the ground at the same time is because in freefall, no matter the mass of the object, the only force applied is Earth's gravity, which is 9.8 meters per second per second.
Again, I plead back. I'm a tech ed teacher.
Give a best guess.
Frame of reference. Not a clue. Let's Google it. There we go. A set of criteria or state values in relation to which measurement or judgments can be made. There you go.
It's a pretty good guess for a tech ed teacher.
And it's a noun, by the way.
From this frame of reference, the ball looks like it is going in an arc from left to right. From this frame of reference, the ball looks like it is going in a straight path. A frame of reference could be described as a set of axes with reference to which the position or motion of something is described or physical laws are formulated.
What is the difference between speed and acceleration?
Speed would be a constant rate in which an object is moving from point A to point B, whereas acceleration would be the increase in speed at the object moves from point A to point B.
And you are correct.
So the difference between speed and acceleration is that speed is the rate at which how fast something moves, and acceleration is the measurement of how fast something moves from point A to point B. For example, right now, Gabe in my car is moving 0 miles per hour at point A. But if he goes to point B, he now accelerated to 25 miles per hour to point B, which took approximately 6 seconds. Doing the math, we can figure out that his acceleration was roughly 416 miles per hour.
That's amazing.
Alright.
Okay. Second question is, what is the difference between the path you walk and the starting and stopping point?
The difference between the path I walk and the starting and stopping point. The starting and stopping point is the start and the end. The path I walk might be straight, it might be crooked or wobbly if I'm walking it, or you know, directionally it could be varied.
Yeah. So like,
The only constant is the A and the B on stop and end, but what's the path might be straight, it might not be straight.
yeah.
Although there are only 2 points, starting and stopping, there are infinite paths of travel in between these 2 points which vary in distances. For example, with these 2 points, only seeing these you would assume that the displacement is the same as the path of travel, but as we can see, the path of travel is much longer than the displacement.
Average, constant, and instantaneous speed.
That doesn't sound like an English to me. I have no idea.
So a constant speed is one rate of motion for the entire path of travel. Like right now, we are going a constant speed of 20 miles per hour.
Average speed is the different speeds traveled added together and divided by the time traveled. So if we go to 20 miles per hour and travel at that speed for 1 hour, and then speed up to 30 miles per hour and travel that speed for another hour, our average speed would be 25 miles per hour for a 2-hour long trip.
And instantaneous speed is if the object moves immediately from its starting position to a constant rate of speed. For example, from our frame of reference, Gabe in my car instantaneously got to 20 miles per hour from his starting position.
How do speed and velocity relate to each other?
Aren't they pretty much the same thing?
So like speed is like the constant, or speed is the constant speed that you're moving, and velocity is the speed and like that you're going in a given direction.
Okay.
So right now, we are going 20 miles per hour in the southern direction. But up here, if we take a right turn, we are now heading west at a 20 mile per hour speed. And up here, again, if we take a second right turn, we will then be traveling 20 miles per hour in the northern direction. So now our velocity has changed 3 different times, but our speed has stayed the same through the entire drive.
Old MacDonald had a farm and it exploded. It tastes really good and it's real special.